Yeah, I promise that'll be the last dad joke. I've excised all of them that I could from this talk. So let's begin. So this talk is going to be about service workers and web workers. And if you've been following any of the hubbub on the internets for the past year or so, you might have heard some breathless commentary about how service worker, it's a revolution of the web platform, right? Like this is Ponyfu here saying that. We've also got, let's see if I can turn these off. Oh my God.
Oh.
Everybody stop tweeting right now. Just like, oh, you know what? You know what? Offline first, baby. This presentation works offline. All right. You might have also heard Malte Ubel. He's the tech lead on the AMP project at Google. And here he says 2016 will be the year of concurrency on the web thanks to web workers. So service workers, it's a revolution, and web workers, it's going to define 2016, right? So like a very reasonable reaction when you read this kind of stuff is, okay, is this just another case of all aboard the hype train? like we're all kind of used to this with JavaScript, and it gets a little, it can be a little overwhelming sometimes. But what I'd like to do with this talk is I'd like to hopefully convince you that actually the hype around service workers and web workers is justified, and that these APIs really do have the potential to fundamentally change the way that we build websites and to vastly, vastly improve the user experience of our web pages. So first off, who am I? I'm this guy. Hi, I'm Nolan Lawson. I work for Microsoft on the Edge team, who we've just released Edge 14. And this is not our marketing campaign, but I kind of wish it was, because I like this kind of retro vibe for this thing. But we released this just this week, so if you're on Windows, you probably already have it. If you're on Mac and you don't already have it, you should go to edge.ms, and you can get a virtual machine, and you can run Edge right now. Who here tests in Edge? Please test in Edge. Yeah, Edge 14's got a lot of cool stuff. We shipped Fetch. We shipped, what else? We shipped web notifications. A lot of ES6 stuff, so yeah, go check it out. So first off, I want to start off by talking about web workers, because web workers and service workers are two very deeply intertwined concepts. But web workers are kind of the older spec, and they're better supported in browsers. And I think that understanding web workers gives you a good basis for understanding service workers, because they have a lot in common. And when explaining web workers and explaining where they came from, whenever we add a new API to the web platform, we got to justify why this thing exists. Why should you expend mental energy thinking about yet another web platform API and what it can do for you? Well, to explain where web workers come from and why they're needed, I like to trot out this little example, which you can try this at home. You can try this experiment yourself in your own browser. All you need is a regular old animated GIF on any old web page. And then what you should do is you should go into the console and do some kind of long-running JavaScript operation, just anything. Here, I'm doing math.random in a loop. And what you'll notice is that the animated GIF just comes to a complete halt, just comes to a grinding halt. And you can reproduce this in all the browsers. You can reproduce this in Safari, Edge, Chrome, Firefox. They all exhibit this behavior. Now, that'd be bad enough if it was just animated GIFs, right? We love our GIFs. We want our GIFs to keep going. We don't want them to stop. But as it turns out, this actually applies to just about everything on your page that moves. So it's not just animated GIFs. So if you've got HTML5 video, if you've got CSS animations, JavaScript animations, all these things are blocked by JavaScript. If you've got form elements in your page, you actually can't interact with them while that JavaScript is running. See, I can't even input into this box. I can't even check that checkbox. The page is just totally non-functional while JavaScript is running. Now, many of us know why this is. It's because JavaScript is single-threaded, and the DOM is single-threaded. So when JavaScript is doing something, the DOM can't do anything, and vice versa. But that's kind of a mind-blowing thought if you actually let the gravity of that statement sink in on you. Because when you actually fully grok what that means is that every line of front-end JavaScript that you've ever written on your web pages has actually completely stopped the page from working. That's what that means. And when you realize this, it really gives you an idea of the responsibility that we have when we're using JavaScript on our pages. Now, many of us know this, and we know that we can block the DOM with JavaScript, and so we know not to do gigantic for loops that do math.random over and over again. We don't actually write code like that, right? But have you ever seen a page or made a page that kind of look like this? So watch those animations. It's not so much that they're completely stopped for milliseconds on end. It's that they kind of start and kind of stop and kind of start and kind of stop. And the page is usable, I can interact with it, but the scroll bar gets a little stuck, right? When I'm trying to scroll around. And like this page is usable. It works. It's OK. It just doesn't quite feel right. There's something off about it, right? And this goes by many names. We call this jank or stutter or jitter. And what this is this is not one big, long JavaScript operation that just totally freezes the page. This is lots of little JavaScript operations adding up over time. This is death by 1,000 cuts. And I think this is the more common experience on the web. Like when we talk about jank on the web, this is usually what's going on. Now, I'm not getting up here to say that we should stop using JavaScript. And like that, I mean, JavaScript is amazing. We love JavaScript. I love JavaScript. We want interactivity in our pages. But we have to be judicious in our use of JavaScript. And it's useful to understand exactly how much JavaScript we can get away with before we start to see this sort of janky effect. And to figure that out, we can use a little math. So most screens are set to refresh at 60 frames per second, which means that they flash 60 images in rapid succession, right, which gives the illusion of motion. It's exactly like this old-timey flipbook. Like, it is the same parlor trick. They were still using it in the 21st century. It just works a lot better now because we're flashing more images faster. And it turns out that 60 frames per second is about the limit of what the human eye can detect in terms of what looks smooth versus what looks janky. So if you start to drop below 60 frames per second, that's when you start to get this like stop motion kind of looking thing. So it turns out that if you take this number, 60 frames, and you take 1,000 milliseconds in a second, you divide it by 60 frames, you get this number, 16.7 milliseconds. This is a very famous number, because what this number tells you is it tells you how much work, how much JavaScript you can get away with in one turn of the event loop before you start to drop frames, before you start to get this janky effect. And if that seems like a punishingly small amount of time, 16.7 milliseconds, to do all your JavaScript, it really, really is, especially on mobile devices where CPUs, like, they don't have as much horsepower, but you still are constrained to the same number. You still want to get 60 frames per second. If you factor in other things like what is your framework doing, what are your third-party libraries doing, what's the browser doing, this ends up being more like 10 milliseconds that you got to work with. And when faced with this fact that JavaScript is single-threaded and the DOM is single-threaded, I feel like the reaction from a lot of JavaScript and web developers is, oh, we've solved this problem because we have asynchronicity, right? Like, yes, we know that JavaScript is single-threaded, but that's what all this, callbacks and promises and event listeners, that's what all this stuff is for, right? Like, that solves this problem. That's why Node is so great, right? Because Node has non-blocking asynchronous I/O. That's the pitch, right? And yes, that is true. It does mitigate the problem. But here's the thing. So a lot of JavaScript developers believe this myth. And I was actually guilty of believing this for a long time before I realized it's not true. That when you invoke an asynchronous API, like for example, here's $.getJSON from jQuery. This is just classic AJAX, right? So when you invoke this API, we believe, oh, everything from when I invoke this asynchronous function to when I get the callback, that's all free, right? That all runs on a background thread. That doesn't block the DOM at all. Except it does. Now, this doesn't fully block the DOM. It doesn't 100% block it. And it varies from browser to browser, and it varies from API to API. But that number is never 100%. It's never 0%, but it's always somewhere in the middle. And you can test this by just testing these APIs in browsers. So for example, IndexedDB. IndexedDB was kind of sold as like, oh, it's better than local storage because local storage is synchronous and IndexedDB is asynchronous, so it doesn't block the DOM, right? Except it does if you actually test it in browsers. So I have this tool called Browser Database Comparison. You can test local storage, Web SQL, IndexedDB. They all block the DOM in browsers, even the asynchronous ones. Like, I can easily block the DOM just by doing IndexedDB operations, and this is all callbacks. Now, this varies from browser to browser. Different browsers are worse or better at this. But this can surprise a lot of people who just expect callbacks to be free. Another thing that may surprise you that blocks the DOM, XHR. Yes, regular old asynchronous XHR can block the DOM, absolutely. And if you don't believe me, then I encourage you to just do $.AJAX in jQuery and just do a bunch of them. And you can easily block the DOM doing this. Now, the easiest way to block the DOM with this kind of stuff is to do things like to request images, because image decoding, that happens on the main thread. To do things like downloading large JSON files and then parsing that JSON. Guess what? JSON.parse, that runs on the main thread. And XHR itself, like networking, a lot of networking stuff under the covers, at least partially runs on the main thread. So think about all the little third-party libraries or third-party scripts that you might have in your web page that are just nicking away at this tiny, tiny, tiny 16.7 millisecond budget that you have. Like, that's what this is doing. And this thinking that asynchronous is free extends so far. I remember that there was a blog post a couple months ago about how, Fetch has this API, response.json, and that's a promise for parse JSON. right? So since that's a promise, that means that's free, right? So we have non-blocking JSON parsing in the browser now. Ah, it's amazing, right? Fetch is great. Unless you actually test it in browsers. And I tested this in all 4 browsers. And in all 4 browsers, this .json API on fetch, it blocks in all 4. In Edge, Safari, Firefox, Chrome, they all block just as badly as json.parse. So let's review. So stuff that blocks the DOM that may surprise you that it blocks the DOM. IndexedDB, XHR, json.parse, of course it blocks. It's synchronous. Fetch, as I just demonstrated. Garbage collection. Even if browsers, we try to optimize, we're constantly trying to optimize, we're constantly trying to move things onto background threads. Even if we do that, you're still allocating event listeners. You're still doing structured cloning. You're doing stuff that's going to cause garbage collection. Garbage collection runs on the main thread. And then you've got, everything else you're doing in your 7 megabyte JavaScript application that you ship down the wire. Actually, this is very germane to Rebecca's talk. So the point I want to get across is that JavaScript just blocks the DOM. And the more that you are doing inside of your web page, the more likely you are to see this janky effect, just because of the nature of JavaScript. Now, luckily, as it turns out, there actually is an API that can solve all of these problems. And that can give you a way to run JavaScript without blocking the DOM for a single nanosecond. And it actually works in all the browsers. And that API is web workers. I spent a lot of time on this graphic, so I hope you enjoy this. I put the fancy graphic up to remind myself to take a drink. Thank you. So what web workers do is they give you a way to escape this single-threaded environment that we're usually confined to with JavaScript. They give you a way to take some JavaScript and to run it on a background thread. 100% on a background thread, no frills. It really does not block the DOM at all. And the way it works is super simple. You don't even need a library or a framework or anything for this. This is all the code in the world that you need to run a web worker. You've got your main JavaScript on the left. You've got your worker JavaScript on the right. And anything you do inside of this worker JavaScript file does not block the DOM at all. Cannot block the DOM. Absolutely. You can compute prime numbers. You can compute digits of pi in there all day long if you want. It will not block the DOM for a second. And you communicate with it using asynchronous message passing. Now, that should set off alarm bells in your head if you've been listening to the rest of my talk. And yes, it is true that this asynchronous message passing is not 100% free. But as long as you keep the messages small and infrequent, this is usually not such a big deal. And I have a blog post at the end of this where I explore some ways to eke out performance wins in that API. Web workers support is very, very good. IE 10 and above, Android 4.4 and above. Can I use web workers? Yes, you absolutely can, and you should. And this really does solve all of these problems. Like, here's that same example I was giving earlier. As soon as I switch IndexedDB to using web workers, I am incapable of blocking the DOM. Try as hard as I might, it doesn't matter how much I bump this up, I cannot block the DOM. Who's using web workers? Lots and lots of websites. This is just a partial list. Khan Academy, VS Code, they're using it for syntax highlighting and parsing. A lot of HTML5 games are using this to try to achieve the maximum FPS. I feel like, though, right now, the sites that are using web workers are mostly sites that are like, oh, I have some long-running computation I want to do. OK, now I'll use a web worker. I feel like every site should be using a web worker, because every site can benefit from these frame rate improvements. And I put together this website a little while ago called Pokedex.org, which demonstrates this idea that I had that web pages should just always use web workers by default. And the way that it works, I have a whole blog post linked at the end of this that explains how it works. The way that it works is that every interaction from the user immediately fires off an event to a web worker, and it does all the computation inside there. It does AJAX, does IndexedDB, does all the business logic, does virtual DOM diffing inside of the web worker, and then fires off the message back to the main thread. It's early days for this. There's been some research on this. Angular 2 is experimenting with this. There's been some experimentations in React to run React's DOM diffing inside of a web worker. But so far, the research is looking really, really good. It can vastly improve the frame rate performance of web apps. And I have links at the end of these slides if you're curious to learn more about that. OK, so spent a lot of time talking about web workers. Let's get to service workers. So why do service workers exist? What problem are they solving? Well, to put it very, very bluntly, the problem that service workers solve is this one. Which, this dinosaur is very cute, and this game is pretty fun, but I mean, this is not the experience that we're trying to deliver to our users. How many people didn't know that there's a game in here? Yeah, it's actually, it's really fun, actually. We should add something like this to Edge. We should, if anyone has any ideas, send them to me. And service workers fundamentally are very, very similar to web workers. Basically, everything you can do with a web worker, you can do with a service worker. They have very similar aspects. Like they run on separate threads, separate processes usually. You communicate with them with post message. The difference with a web or with a service worker is that it has an additional superpower on top of web workers, which is that it can intercept requests from the main thread and then serve back whatever response it wants. So you can use this to like go to the cache and then give a cached response. You can fire off a request to the cache and the network and then just give the user whichever one came first. And this is what enables offline scenarios. Support for service workers, not so great. It's a newish spec, so it's just now getting implemented in browsers. It is in the Chromium browsers and Firefox. And then if you go to this site, is service worker ready, you will see Edge listed there because we are working on it. Like it is actually in development right now for Edge. We kind of couldn't not work on it because we did this thing where we went out to web dev shops and asked them, hey, what features in the web platform are you most excited about? Which one, what should we be working on? And service worker came in at #1 by like a huge margin. Like I think #2 was CSS Grid, but like everyone was clamoring for service workers. So yeah, we are working on it. I'm not going to go into a super amount of detail about all the stuff you can do with service workers because there have been so many talks about service workers and you might be tired of it by now. If you're interested to learn more, I would recommend going to this website, Offline Cookbook by Jake Archibald. It has lots and lots of nice diagrams explaining all the different ways that you can do complex caching scenarios inside of a service worker. It's a really great site. OK, so breakdown of major differences between web workers and service workers. The first thing to understand is tab control. So when you're using a web worker, you can actually create as many as you want per tab. And in fact, they all run in parallel, and they all run in different threads. Whereas with a service worker, what you typically have is you typically have one per origin. So if you create multiple tabs for the same website, they're all going to share the same service worker. In terms of lifespan, a web worker, actually, it gets terminated the moment that the tab gets closed. So it only lives as long as that tab lives. Whereas for service worker, it's actually independent of the tab, which is really interesting because the service worker can actually outlive the tab. It can be spawned even when the tab isn't open. And that enables things like push notifications and background sync, which are just now getting implemented in Chrome and are definitely on our backlog. And enables things like when the web page isn't even open, you can send a push notification or you can do a background sync. Because you want those things to be able to run even when the user isn't presently on the page. And given their performance profiles and browser support, I would say that web workers are best for doing straight-up parallelism. Like when you want to achieve 60 frames per second, when you want to eliminate jank, you should use web workers. And for offline scenarios, you should use service workers. Now, you can imagine a future where service workers are better supported in all browsers, and then maybe you would just use service workers for the stuff you used to do with a web worker. But I mean, today, it's perfectly fine to use both a web worker and a service worker. That's what I did in the Pokedex app. It makes perfect sense. I mean, these machines have multiple cores. You know, you can use a web worker and a service worker. You can use multiple web workers if you want. Like, milk those cores. You know, make use of them. So I'm going to finish with some pro tips because when I recommend to people, and I recommend people a lot to start moving their code into web workers as much as possible, they start to run into some little edge cases that often don't get discussed. So the first thing, and kind of the most obvious thing, is that when you're inside of a web worker, you don't have access to window or document. So there's a lot of libraries just out of the box that aren't going to work, like jQuery, right? And that's because that's by design. We actually want that to be the case, because you should not be able to access document or window. You shouldn't be able to access the DOM from inside a worker. We want it to be jank-free. We don't want them to be able to jank the DOM. But there's some other APIs that you may be surprised aren't supported inside of workers. So, like, for instance, there's no local storage. There's actually good reason for this, which is that local storage is synchronous and blocking, and those are bad things. So you should be using IndexedDB, preferably. But also it has race conditions, so that's why we mostly just punted on not putting them inside of workers. You may also be surprised there's no XHR inside of service worker. There's only fetch. So a lot of libraries don't work because you have to use fetch instead of XHR. Not the case with web workers, but it is the case with service workers. And then you also just run into kind of strange things in browsers, like Firefox only recently added file reader to workers. Safari doesn't have IndexedDB. They are shipping it in 10 now. And then in Android 4.4, you actually don't have console, so you can't even console.log inside of a worker. So lots of people run into these issues, and they're very surprised by them. So when you're trying to research this stuff, there is a very good resource on this, which is MDN, which I've used this resource many, many times in the past. It's great. Functions and classes available to web workers. The problem with this resource is that it's manually curated, and so it can get out of date really quickly, like as browsers add or remove things. So I wanted to solve this problem, and I wanted to give web developers better insight into what actually is going on inside of workers so that it's not so mysterious, like you kind of like fire off code into this thing and like, what's it doing in there and why aren't these APIs available? So I built this tool, which I am now unveiling at CascadiaFest, which is called HTML5 Worker Test. And you can go to it right now. It's html5workertest.com. And what this is this is a tool that runs in the cloud on Travis and Sauce Labs. Shout out to Sauce Labs for being amazing. And it tests various browsers. It tests various versions of those browsers. And it reports back exactly which APIs those browsers support in both web workers and service workers, because it is different between the two. And you can actually go into this, and you can see, for instance, that Safari doesn't support XHR inside of a web worker. Or you can see that Chrome and Safari dropped support for WebSQL a few versions back. Or Firefox added support for File Reader a few versions back. Or Edge supports SendBeacon, but the other ones don't. Or you can see exactly when Android added support for console. So, and by the way, the point of this was not to like let one browser win or another. I didn't even like attach a score to any of these things. I think if there was a score, actually Firefox would win. I mean, that was not the point of it for me. The point of it for me was to give web developers a tool so that they had more insight into what's going on inside of web workers and service workers. So I hope this tool is valuable to people. You can go there and test your browser right now, if you like. I'm not going to actually show the site because I'm running short on time. So yeah, that's html5workertest.com. Go check it out. I'm hoping this can be a really, really useful resource for people. And it's all open source, so go ahead and fork it if there are bugs in it. Hopefully there are no bugs. Some other stuff that I found as I was working with workers, I said you don't need a framework or a library to work with web workers or service workers. That is true. It can really, really help things to use some libraries, though. I found that communicating with workers was kind of complicated, dealing with event listeners and this post message API. So I wrote this tool called Promise Worker, which can basically wrap a web worker and a service worker and allow you to send messages to it and then get a promise for the response. So it just really cuts down a lot of boilerplate code and also makes it really easy to work with service worker because it turns out that post message is actually really hard inside of a service worker. So one thing you might use this for instance, is armed with the knowledge that certain browsers support certain APIs inside of web workers, you might want to feature detect, right? Because that's the responsible thing to do. So you might want to fire off a message to the worker and say, hey, do you support IndexedDB? Do you support XHR? Do you support this thing that I need? And then maybe the worker will come back in a certain browser and say, nah, man, sorry, I don't support that. In which case, you would want to fall back to running that same code on the UI thread instead. And I wrote another tool to allow you to do that. So that is sudo worker. So sudo worker is just a polyfill for web workers that runs entirely on the main thread. And both of these things are open source. They're on NPM. Go ahead and use them if you could use it or if you find utility in them. This thing can also be used in browsers that don't support web workers as well. So if you need to support like IE 8 and above, then you can also use this for that. So I wanted to close with one thought, which is that there's a reason that I get personally really excited about web workers and service workers, and that is that I did native Android development for many, many years, and I was just as much a performance geek when I was doing native Android as I am now, building stuff for the web. And when I thought to myself, like, what am I doing when I'm doing native Android development? Or what are my coworkers who are doing iOS development? What are we doing that to eke out like the best possible performance on these constrained mobile devices that I'm not really finding myself doing so much when I'm doing web development? And when I thought about it, it really came down to two things that I found us doing, which was parallelism, like actually milking the cores on a smartphone, actually doing more than one thing at once, and offline, right? Not just going to the network every single time you need something, avoiding those network round trips, not trusting the network, because the local cache is always faster. And we have these tools on the web. We have web workers, which are very, very well established. They're getting better all the time. Browsers are constantly adding new APIs and filling in these holes that I mentioned earlier. And we have service workers, which are now just starting to be released in different browsers and give us full offline access. They give us a full client-side proxy to handle the network. And these two things, I feel, really allow us to build websites that are jank-free and that work well offline, which are huge game changers for the web. So I hope that you'll start looking into web workers and service workers and that this makes a little bit more sense to you, how exactly they work and what they're good for. Thank you. Oh.